I have here a section of dowel fixed to a disc, attached to a rotary sensor. For this experiment, I'll be shooting the dowel in 2 different positions with a low-powered air rifle. In the first position, the velocity of the slug is roughly perpendicular to the dowel's radius. In the second position, this angle is less. Comparing the two, we see the perpendicular shot disc rotating at a much higher angular velocity, having experienced a much higher angular acceleration. This happens because the torque applied to the disc is equal to the radius multiplied by the component of force perpendicular to the radius. The radius is kept constant, and while we can assume the force is approximately the same in each case, in the first position, all of the force is roughly perpendicular, while in the second position, the perpendicular component is smaller, resulting in a smaller torque, smaller angular acceleration, and smaller angular velocity. The component of force that doesn't act to produce a torque and therefore an angular acceleration, instead acts to produce linear acceleration, which we see a hint of in the more pronounced wobble of the disc. Repeating the experiment on a smart cart, we can observe and measure the difference more clearly.